Hi again. Welcome to week 3. During the last 2 weeks, we looked at the internet as an infrastructure supporting applications. We looked at 5 different applications as an example. Now we are going to look at how one host sending data to another host on the network actually works. The application layer passes data down to the next layer, the transport layer. The goals for this week are understanding the principles behind the transport layer services. These include multiplexing, demultiplexing, reliable data transfer, flow control, and congestion control, as well as learning about the 2 main transport layer protocols, UDP and TCP. The transport layer runs only on end systems. This layer provides logical communications between application processes running on different hosts. The sending side breaks application messages into segments, passes them to the network layer. The receiving side reassembles segments into messages and passes them to the application layer. Via multiplexing and demultiplexing, the transport layer extends the delivery service between 2 end systems to a delivery service between processes running on the end systems. Multiplexing does the job of gathering the application layer data into chunks, encapsulating them, and passing them to the network layer. Demultiplexing is the process of taking the received chunks or segments from the network layer and de-encapsulating them and sending them to the application layer. To do this, the transport layer header includes a destination port number that identifies the destination application program on the remote machine, and a source port number that identifies the application on the originating machine. Let's look at UDP versus TCP. UDP is a bare bones protocol. It provides a connectionless service. No handshaking to set up the conversation. It is analogous to sending a letter. Each UDP segment is handled independently. If the segments are lost or received out of order, UDP itself cannot fix it. As a consequence, UDP does not guarantee delivery. Another way of saying this, the sender just casts the application layer data at the receiver and hopes the receiver gets it. One of the main challenges for the development of the internet was to figure out how to achieve reliable communications between devices over a noisy and lossy medium with limited resources. TCP to the rescue. TCP, in contrast to UDP, was developed as a connection-oriented protocol. In TCP, the sender and receiver communicate with each other to set up and regulate the flow of application data. A simple analogy for TCP is a phone call. TCP is designed for a conversation between one sender and one receiver. We will see that TCP provides for orderly data reconstruction and flow control. Once the reliability problem for a pair of communicating devices was solved, then the next problem was to figure out how a large number of devices can share the communication medium. We will look at 2 of the different algorithms that have been developed to help TCP handle congestion control. This chart provides the contrast between UDP and TCP. You can see that UDP is faster than TCP and can support broadcasts. But if your application really needs reliable data transfer, TCP is the choice. Well, that's it for the introduction for this week. Read Chapter 3, except for Section 3.4, and look at the related videos. For this week, complete the Chapter 3 quiz and assignment as well as your journal. Complete Lab 4, the Wireshark DNS lab, and Lab 5, the Mininet iPerf traffic measurements. Finally, this would be a good time to start preparing for the midterm, which is coming up in 10 days. The midterm is open book. and covers the video and textbook for chapters 1, 2, and 3, and labs 0 through 4. The midterm does not include section 3.4 of chapter 3, except for the opening page of this section and table 3.1. It also does not include the material that will be introduced in week 4.